Okay, so welcome everyone. Welcome to the third demo session about this CCNP plus CCI program. About this CCNP plus CCI program. So I'll just give a recap of what we had discussed in the second demo session, which was purely a technical session. All right. So we started discussing about the working of switch, right? How switch basically works using a MAC address table, right? And we also discussed what a MAC address basically looks like. Okay, so we know that MAC address is a 48-bit value, and it is unique for all devices, and it is written in a hexadecimal format. Right? And we started discussing about how switch works, assuming two things, where all the devices that are connected to the switch are know each other's MAC address. That was one assumption. The second assumption was that the MAC address table of the switch is completely empty, right? This is what we had assumed. So what we discussed and what we learned in the last session was whenever a switch receives a particular data, right? So the switch learns the source MAC address and the interface that it received the data on, and it populates its MAC address table. Okay, so for example, PC1 is sending a data to one of the PCs. Let's assume one of the PCs, let's say PC number 4 in this case, right? So when PC number 1 sends the data to switch, right, the switch notes down PC number 1's MAC address because that is going to be the source MAC address and the interface that it received on. So for here is the MAC address table. So 1111 is the MAC address of the PC and it was received on interface number 1, right? Now, when it is trying to send the data out of its interface, it checks the destination map. Now, to check the destination, to check the destination MAC addresses, it has few criteria. The first criteria is if the destination MAC, I've written over here, if the destination MAC is not present in the MAC address table, the switch will broadcast it out of all the interfaces, right? That's the first criteria. So let's say that PC1 is trying to send the data to PC4. And here, as we can see in the MAC address table, the destination MAC, that is 4444, is not present in the MAC address table of the switch. So the switch is going to forward the data out of all the interfaces, connected interfaces, right? That's the first, that's how the switch works. Then, second thing is if the destination MAC is present in the MAC address table, for let's say here, instead of PC number 4, it's PC number 3, and the MAC address over here is 3333. Okay, 3333. So now when the switch receives it, it knows the destination MAC address already because it's present in the MAC address table. So it will forward the data out of that particular interface rather than broadcasting it. Right. This is what we had discussed in length in the last session, theory plus lab both. So we had discussed this using one switch. We had also discussed this using two switches as well. How the switches will forward data when there are multiple switches involved. Okay, what we had discussed. So in conclusion, there are three. Sorry, there are three types of layer 2 traffic. When I say layer 2, I mean layer 2 of an OSI layer model. Okay, that is data link layer, layer 2 traffic. There are three types of layer 2 traffic that a switch forwards. That a switch, that a switch forwards. You can think. So the first one is unicast. Okay, unicast, meaning that there is a source MAC address in the data, there is a destination MAC also present in the data, and this destination MAC is present in the MAC address table of the switch. Okay, it is present in the MAC address table of the switch. So what the switch will do, this is a switch. So the data enters the ingress interface. We all know that ingress in technical term means the interface or the entry point of any data, right? Ingress interface. So the data enters the ingress interface. The switch makes a note of the data using the source MAC address. And when it is sending out the data, it reads the destination MAC address, and the destination MAC address is present in the MAC address table, right? And out of which or to which interface should it send it out of? That is also mentioned. So the switch uses that information and sends it out of the egress interface. That is unicast traffic. Okay. Now, the second traffic is the broadcast traffic. Broadcast traffic, where the source MAC is present, the destination MAC is also present in the data. However, this destination MAC is not exclusively is not in the MAC table. In the MAC table. Okay. Now, this broadcast destination MAC is basically all the digits of the MAC address is FFFF. That is the broadcast MAC address. Right. So this destination MAC address is not exclusively present in the switch's MAC table. But when the switch reads the destination MAC as all F, it automatically understands that it doesn't have to basically check its MAC address table. It can simply forward it out of all the interfaces. Okay, that's basically broadcast. Then the last traffic is unknown unicast. Unknown unicast traffic. Okay. Now, unknown unicast. It's a bit tricky term. Okay. Where the data has the source MAC address, the data also has the destination MAC address, but this destination MAC address is not in the MAC table. Okay. It's not in the MAC table. That means it is a unicast. The data has a source MAC address. The data also has a destination MAC address. However, the destination MAC address is not present in the MAC address table of the switch, which we just saw. When the destination MAC address is not present in the switch's MAC address table, the switch will basically broadcast it out of all the interfaces. Okay. So the example that we saw over here, where the okay, this is PC number 4. This is a unicast packet. There is a source MAC address, there's a destination MAC address. However, this destination MAC address is not present in the MAC address of the table. And when the destination MAC is not present in the table, what the switch does, it will broadcast the packet. So that is what you call it as unknown unicast packet or an unknown unicast traffic. All right. So these are the 3 types of traffic that a particular switch deals with. Okay. And in when we go into an advanced topic called as multicast, I will also write down the 4th type of traffic, that is multicast traffic, which the switch also deals with. However, I'm not bringing that into the discussion currently. All right. So there are 3 types of traffic that a switch deals with: unicast, broadcast, and unknown unicast. Okay. Any question till here? This was a recap of what we learned last class, what we learned in the last class. Any question? Anyone? No? All right. Now let's move to our next discussion. That is VLAN. That is VLAN. Okay. So before I Before I discuss the the concept of VLANs, okay, let me just discuss a bit of a history of why VLANs were introduced or why switches were introduced. So I believe that, okay, and this is purely my assumption, okay, and I'm extremely sorry about the background work background noise. There's some work going on in my apartment, not in my apartment, nearby apartment. You may hear a lot of background noises, so I'm extremely sorry about it. Now, I personally believe that the uh, computers, okay, a computer was invented to make any mathematical calculation faster. It was basically created for that purpose, to make mathematical calculations faster, complex mathematical calculations faster. Okay. Any complex mathematical, calculation for a human probably may take, if he's good at maths and whatever the formula is involved in it. If he's extremely good, probably he may take 15 minutes of time to basically solve that particular thing, complex mathematical calculation for research purpose. Right? But the same thing, a computer probably could do it in 2 minutes. Okay, so that was the reason why a computer was created to make mathematical calculation faster, to predict analysis or predict the futuristic result given to it. Okay, there is a I'm not sure if you have seen this movie. There's an extremely good movie called The Imitation Game. The Imitation Game. Okay, it's an extremely good movie. The hero or the main character is Benedict Cumberbatch, who was acting as Doctor Strange in the Marvel movies. Also, he acted as Sherlock in the Sherlock series. So he's the lead guy. And I'm not sure how many of you know that for any computer to be launched, to be a product, or any AI engine to be a product, it needs to pass a Turing test. Turing test. Okay, I'm not sure how many of you know this. Okay, it needs to pass a Turing test. Then only it is fit to be used by any user. So the Turing test was based on this guy. I'm not sure of his full name, but his last name is Turing. So he created the not the first, but he created a complex computer machine which would predict Germany's war plans with the existing plans that it has. It would predict Germany's war plan, and you won't believe that machine helped reduce the war for 5 years. It reduced the war time of 5 years because it could predict what the Germany would do, and it helped France and Germany. I think, if I'm not wrong, France or England. I'm not sure which two countries. Okay, was he from France or was he from England? I'm not sure. So it helped them to predict Germany's move, and it brought down the war time. It reduced the war time by 5 years. Okay, so if you think from that perspective, computers were created for that purpose, to make our complex analysis or equations easier for us to understand. So now what happened was, as more and more computers started to come up, we wanted these computers to exchange information with each other. Okay, we wanted these computers to exchange information with each other. So what we did, we started connecting these machines together. Okay, so that every computer can send data to each other or can share the data with each other. Now, if you see over here, one single computer is connected to three different computers. So on a single computer, I need three interfaces or three connectivities to share its data with the other computers. Okay. Now imagine that in a in a single room, there are, let's say, 100 computers. Okay, so one computer would be connected to other 99 computers. So just imagine the number of interfaces you need on a computer. Imagine your laptop, you're sitting on your laptop or you're watching it on your mobile. I'm not sure if it's laptop or if it's a PC. Imagine there are 99 interfaces on your laptop. How bulky your laptop would be. Okay, how heavy it is going to be and how ugly would it look like, but just interfaces. Okay, so that connecting 99 computers together was not it was feasible. I would say it is not impossible. It was it was obviously possible, but it was not feasible, right? So what we did is we wanted a device which would help us connect all these computers together without the need of having multiple interfaces created. That is why we went for a device which was called as a hub. Okay, we created a device called as a hub. So what we did, we connected these computers to the hub, right? And without the needing of creating multiple ports on the computer. So now, when the PC1 sends a data to the hub, okay, what the hub is going to do, hub will basically copy the data and forward it out of all the interfaces. Okay, so basically it was like a copy, duplicate, and broadcast. This was basically the work of a hub. The data comes, it copies it, it makes duplicate copies of it, and broadcasts it out of all the interfaces. That was the work of a hub, right? So now for 99 computers, all you need is 100 computers. All you need to do is connect all these 100 computers to this particular device, hub device. Okay, so any computer which sends the data, it will basically copy it, duplicate it, and broadcast it to other 99 devices. That was easy. But then, as more and more computers started to come up, what I wanted was, I wanted, obviously, if I'm sending one particular data, not every user in the room would require it. Okay, let's say I am sending a data, only 50 users want it, the rest of the 50 users do not want it. So what's the point of sending or wasting hub's energy to by sending those data to 50 other users? It's a waste of hub's energy. But then hub was designed like that. So hub was basically the first unintelligent networking device. Okay, unintelligent networking device. I mean, it is intelligent, but it is not doing the work that I want. It is just simply copying and broadcasting it. But I wanted something, let's say, I do not want these two users, two or three, okay, to be receiving the data that I'm sending, probably because they are not from my department, or probably they are not even interested into listening to my data, right? So I wanted some kind of a device which would just send the data to the host that I want. So I want the data to be sent from PC1 to PC4 only, to these two devices only. Okay, I do not want the data to be sent to 2 and 3. That is why I created the device switch. And we know that switch uses MAC addresses. That is where your MAC addresses were involved. The switch used MAC address to read the source MAC addresses, to read the destination MAC addresses, and forward the data based on what we learned in the previous few classes. Okay, so switch was the first intelligent device where it could send the data based on the MAC address table and the data present in the MAC address table. Right. Then what happened was, as more and more, technology started to come up, we wanted these computers from different geographical location. I mean, in the same area, let's say it's a university. It is a university. And we know that in university, there are a lot of computers. So I wanted that all the computers in the university should be connected to each other. Okay. So I wanted to expand my network. And in last class, we know how to expand the network. Connect this particular switch to another switch, connect few more switches over here, right? And then you can just simply expand your network. Okay, then you want to expand it even more or grow it even more, connect few more switches, right? Connect few more switches and connect the users to these switches. And again, your network has grown, or you can scale your network, right? Now, with such a scalable network, what I wanted is, let's say that, as I said, it's a physics, it's a it's a university. Let's say physics department. So PC, all the even number, all the even number PCs are physics department. Okay, so 4, 5, 6, 7, 8, 9, 10, 11, 12. So all the even number PCs, are physics department. So there is a physics professor who wants to share, and a physics article or his physics thesis with other physics teacher to have a peer review so that he can apply for a PhD. Let's assume that. Okay. So what this physics teacher would need to do is, from PC number 2, he needs to send a single data to PC number 4 using the source MAC address, destination MAC address combination. Then he needs to send another data to PC number 6. He needs to send another data to PC number 8, then PC number 10, then PC number 12, right? Or all the even number PCs. He need to type in on his computer this source MAC address, destination MAC address combination every single time. Okay. And in this particular topology, there are just few physics teachers, but you know that in a university, there are not just 3 or 4 physics professors. There are many, probably 10, 20, 30 physics professors. Okay. Teaching different physics topics to the to different batches in the university. So it was time consuming for this particular physics teacher to type in everyone's MAC address and send the data, right? So we came up with one more technology or one more feature, which basically, if I have to talk from today's term, it's like a WhatsApp group. Okay, WhatsApp group. So instead of sending individual messages to everyone, what I did, I created a group. Let's say I created a group called as physics group. Okay, and anyone in this group sends a data, it would be sent to everyone who is a part of this group. Correct? That's what a WhatsApp group does. I am sending a data. Let's say I sent a physics paper. So whoever is member of this WhatsApp group would receive that physics paper only. No one outside the group would receive it. Similarly, we created a concept called as VLAN, or I would have to say it as a virtual LAN. Virtual LAN, or in short, it is called as a VLAN. Okay, so over here, what I did, I created a WhatsApp group or a VLAN. VLAN specifically for physics teachers. Okay, now what this physics teacher all need to do is, he just needs to send the data to the physics department, and all the physics teachers or all the teachers who are part of this physics VLAN would only receive the data. That is the purpose of VLAN, to send data to a common group of users who are part of that VLAN or who are part of that group. That is the purpose of VLAN. Now, why virtual LAN? Why is it called as a LAN, first of all? Because if you see this particular topology where there are 3 switches and multiple PCs involved, they are forming a small local network of themselves. A local network, where local meaning this particular network is of the university. This particular network is of a university, and it's a very small area. That is why it's called as a local area network, LAN, local area network. Local to themselves, a small area, and it's a network. Local area network. Now, what I wanted to split this LAN into smaller individual LANs. That is why I called it as a virtual LAN. Okay, virtual, or basically it's an imaginary segmentation or imaginary splitting of a LAN into smaller parts. That's what you call it as virtual LAN. Okay. Now, anyone would like to add something that of their understanding of what you guys understand of what a VLAN is? Let's make this interactive. Okay. Yeah,
It's
Jyotsna.
basically we are breaking the broadcast domain so that like
Hmm.
particular users can only get the data which is intended for them.
Right, right. So Jyotsna used a word called as a broadcast domain. Broadcast domain. Okay. Now, what is a broadcast domain? In a LAN network, what is a broadcast domain? So we just read, I just gave a recap of what a broadcast traffic looks like. Okay, meaning that a particular switch, okay, a particular switch would broadcast a particular data if the destination MAC is of FFFF, right? But from a switch's point of view, what is its broadcast domain? Okay, a broadcast domain is a domain where it can reach, hmm, yeah, where it can reach all the users of the same network. So let's say this is one network. Okay, uh, network of, let's say, IIT Bombay. Okay, IIT Bombay network. Okay, so IIT Bombay, Bombay's broadcast domain is people. It can be, when I say people, there are students, there are students, there are professors. Okay, professors of uh, 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 different departments, students of different department. There are staffs. I mean, there are staffs. Okay, there are people, workforce staffs in IIT Bombay, or not just IIT Bombay, every IIT, right? So there are a lot of people. Okay, and all of them are part of IIT Bombay. So they all belong to the broadcast of IIT Bombay. So let's say the chairman of IIT Bombay, if he is addressing the chairman of IIT Bombay, when he is addressing, it would be for everyone who is a part of IIT Bombay. It be it students, be it professors, be it staff, be it work, everyone. Okay. So similarly, over here in a switching network, this broadcast domain means if PC number 4 sends a data, it would be sent to everyone who is connected to these multiple switches, who are part of the who can be a part of physics department, who can be a part of chemistry department, aeronautical department, anything. But if the students union leader, when the students union leader is speaking, it would be only for the students. When he is broadcasting something, union leader of the student, when he is sending or when he is speaking, it is a broadcast only for students. No other people of the IIT Bombay would be interested to what he's saying, right? So we are separating a bigger broadcast domain into smaller broadcast domain based on the interest. That's what VLAN is doing, and that's what Jyotsna said. We are separating a bigger broadcast domain and dividing it into smaller broadcast domains, and we call that smaller broadcast domains as VLANs, virtual LANs. All right. Now, now talking about VLANs. Okay. From a Cisco perspective, we have different VLANs. Okay. The VLAN is basically for a switch. Basically, VLAN is a number. It's not a name. You can give it a name, but I'll talk about that name later. But VLAN is basically a number starting from 1 up till 4096. You can have these many groups or these many VLANs on a particular switch. Starting from VLAN 1 to 4096. Okay. Now, the one most important thing that we have to understand, or whenever we say, whenever we think, whenever we are sharing that information, it can be to our colleagues, it can be to our customers, it can be even to an interview that we are attending. We have to be very specific about our words. VLANs are created on a switch. Okay, on a switch interface. On a switch interface. VLANs are created on a switch interface. The devices which are connected to this switch interface are not part of that VLAN. Okay, end devices. Okay, hosts that are connected to this switch interface, or any networking device which is connected to that particular switch interface is not part of that VLAN. The interface of the switch where we have created the VLAN, it is only the part of that VLAN. PCs, laptops, printers, IPTV, IP phone, your servers, they do not understand VLAN. Okay, PCs, printers, or in other words, end hosts do not understand VLANs. This is the first and foremost important thing that we have to keep in our mind, because in interviews, in some technical discussion, we say PC is part of VLAN 10. No, PC is not part of VLAN 10. The PC, where it is connected to on the switch interface, that switch interface is part of VLAN 10, not the PC. Okay. So here is a switch. Okay, I'm connecting multiple PCs, PC number 1, PC number 2, PC number 3, and PC number 4. So, and if you remember, this is how I started my discussion on how switches forward data. Right. Now, when we are going to discuss VLANs, we are going to discuss not how switches forward MAC addresses. We already know about it. We are going to discuss how switches are going to read VLANs and forward data based on MAC address. Okay. The configuration part I'll talk about later, but let's just understand when VLANs are involved in a switch, how switch is going to read that data and forward it. Okay. So as I said, VLANs are configured on the switch interfaces. So let's say this interface number 1, interface number 2, interface number 3, and interface number 4. Okay. Interface 1 and 2 are part of VLAN number 10. Interface 3 and 4 are part of VLAN number 20. Okay. How do I configure it? I'll talk about that later. But let's just understand. I configured interface number 4 as VLAN 20. I configured interface number 3 as VLAN 20. I configured interface VLAN 1 and interface VLAN 2 to be part of VLAN number 10. Okay. Any question regarding the topology? No. Okay. So now, again, the same assumption that all the PCs, they know about each other's MAC address. All the PCs, they know about each other's MAC address. And the switch's MAC address table is empty. This is what our assumption has been always when I was explaining even the switches forwarding mechanism. Okay, so let me write that down. Assumption one is that PCs know each other's MAC address, each other's MAC. That's our first assumption. Second assumption is that assumption number 2, MAC table of switch is empty. Okay, these are the two assumptions that we are taking. Okay, so let me write down the MAC address table, MAC interface, and since we are also dealing with VLAN, now we will also have a column called as VLANs. Okay. So now let's assume PC1 is sending a data to, let's say, PC number 2. It is sending a data to PC number 2. The source MAC is going to be 1111. Okay, destination MAC is 2222. Okay, MAC addresses are based on the PC numbers 111, 222, 333, 444. Okay, now when PC number 1 sends a data, switch will receive it. Okay, when switch receives it, we know that it reads the source MAC address on the data. It checks if the source MAC is present in the MAC address table. No, it is not present in the MAC address table. So let me make a note of it. 1111 was received on interface number 1. And since VLANs are also involved, this interface number 1 is part of which VLAN? It is part of VLAN number 10. Okay. Then the second thing, it checks for the destination MAC in the MAC address table. The destination MAC is not present in the MAC address table of the switch. And when the destination MAC is not present in the MAC address table of the switch, what does the switch do? What does the switch do when the MAC address is not present in the MAC address table? It broadcasts the packet, correct? But when it broadcasts the packet, earlier, when we do not had any VLANs involved, we could broadcast it out of all the interfaces, right? But here, VLANs are involved. So now the switch checks the receiving interface VLAN is VLAN number 10. What are the other interfaces which are part of VLAN number 10? What are the other interfaces which are part of VLAN number 10? The only interface which is part of VLAN number 10 is interface number 2, right? And hence the broadcast will be sent out of only those interfaces which are part of VLAN number 10. And hence it is sent out of VLAN interface number 2 only. Interface number 3 and interface number 4 will not be sending out this particular broadcast because those two interfaces are part of VLAN number 20. Okay. So now what happens? The PC number 2, it receives the data, right? It receives the data. When it receives the data, it has to respond. PC number 2 is the now source. PC number 1 is the destination. So the source MAC address is now going to be 2222. Destination MAC is going to be 111. Now this data is sent. Switch receives it. Switch reads the source MAC address. Is the source MAC address present in the MAC address table? No. So it makes an entry for it. Okay, it makes an entry for it. 2222. On which interface was it received? Interface number 2. Interface number 2 is part of which VLAN? VLAN number 10. Okay, then it reads, now listen to this very carefully. It reads the destination MAC address. Is it present in the MAC address table? Yes. Out of which interface should I send it out? One. But wait here. Is the receiving interface VLAN and the exit interface VLAN, are both of them the same VLAN? That's the important thing. Now the switch will check when there are VLANs involved. The receiving interface VLAN and the exit interface VLAN, both should be part of the same VLAN. Here, both of them are part of the same VLAN. So now the switch will be sending it out of interface number 1. Any question? Any problem understanding this flow? Abhishek, Jyotsna, Rishikesh, Praful, any questions? Okay. So, guys, if you do not let me know if you do not understand this, or yes or no, I won't be able to infer. Like, if you should I explain this in a better manner, or should I repeat it, or should I not repeat it, or should I move on? Right. So just give
So
me a
Laksh,
yes or no. Yeah, Jyotsna.
yeah. So how does the switch know which VLAN belongs to which interface? How does it read it?
Because we will be
Through the
configuring
VLAN tag, or
here. I will talk about VLAN tag later. I will
okay.
talk about the VLAN tag later. But over here, because we are talking from a single switch point of view, we're talking about
Hmm.
from a single switch's point of view, switch already
Hmm.
knows which interface is part of what VLAN, because we configure it that way, right? Switch port
Yes.
access VLAN 10, switch port access
Yes.
VLAN 20. So with
Yes.
that, the switch already has in its VLAN table, it already knows which
Hmm.
VLAN belongs to what interface. It already knows about it.
Okay.
Okay, so imagine these interfaces as its own body part. So it knows it has two hands, it knows it has two legs, it knows it has one, two eye, nose, etc.
Mm-hmm.
Right. So there is
Hmm.
so the switch does not need much of an intelligence over here to find
Hmm.
out which VLAN does it belong to, because it already knows. That
Okay.
is why the moment it understood that the incoming interface and the incoming interface VLAN is VLAN number 10, it completely
Hmm.
ignored those interfaces which are part of VLAN 20.
Mm-hmm.
Okay.
Okay.
So
Okay.
for this switch, it is like, if I'm receiving on VLAN number 10, I will send it only on VLAN number 10. I will not be sending it to VLAN 20 at all. That's what the switch's logic is on a single switch. Okay.
Mm-hmm.
When
Mm-hmm.
we are talking from a double switch point of view, I'll explain that later.
Okay. Yes,
Okay.
sure.
Now,
Thanks.
similarly, yeah. No. Now let's assume another example where PC1 tries to send a data to PC number 3. Okay. Source MAC is 1111. Destination MAC is 3333. Okay. Now, this data is again received by the switch. Switch takes the source MAC address. Is the source MAC address present in the MAC address table? Yes, it is already present in the MAC address table, so not a problem. Then it checks the destination MAC address. Is the destination MAC address present in the MAC address table? No, the MAC address is not there. Now, when the MAC address is not present in the MAC address table, it needs to broadcast it. But again, what is the receiving interface VLAN? The receiving interface VLAN is VLAN number 10. So it will again check which are the other interfaces that are part of VLAN number 10. In this topology, there is only one interface which is part of VLAN number 10, and this packet is broadcasted to PC number 2. But PC number 2's MAC address is not 3333, and hence this data is basically dropped. When this data is basically dropped and the data is not forwarded out of this interface, PC number 3 eventually never receives this data. And this particular ping or whatever data that PC1 is trying to send to PC3 is never a success. It is never a success because PC number 3 never receives this data, because the interface that PC number 3 is connected to is part of VLAN number 20. And PC number 3 never receives it, and hence PC number 1 never gets a response. That is why this data communication is a failure. All right. Then let's take another example when PC4 is trying to ping PC3. Okay, PC4 is trying to send the data to PC3. Source MAC is going to be 4444, right? Now, PC number 4 sends the data. Switch checks the source MAC. Is the source MAC present in the MAC address table? No. So let me make a note of it. 4444. On what interface was it received on? It was received on interface number 4. Which VLAN does this interface belong to? It belongs to VLAN number 20. I made a note of it. Then it checks the destination MAC. Is the destination MAC present in the MAC address table? No, it's not present. So it will broadcast it. But it will broadcast it only out of the interfaces that are part of VLAN number 20, because the receiving interface VLAN was of VLAN 20. So here 3 is in this topology, 3 is the only interface which is part of VLAN number 20, and hence the data is forwarded out of this interface. PC3 receives it because that's what the destination MAC is of. Right. Now, PC number 3 responds. When PC number 3 responds, source MAC is 3333. Destination MAC is 4444. Right. Now, PC number 3 sends the data. Switch makes a note of the source MAC address because the source MAC address is not present in the MAC address table. So 3333, it was received on interface number 3 belonging to VLAN number 20. Right. Then it checks the destination MAC address. Is the destination MAC address present in the MAC address table? Yes, it is present. Out of which interface should I send it out? 4. But wait, is the receiving interface VLAN and the exit interface VLAN, are they from the same VLAN? Yes, they are from the same VLAN, and hence it will send it out of the exit interface. It will send it out of the exit interface. Okay. Any question now? Anyone? Okay. Now the switch knows every PC's MAC address, 1, 2, 3, 4. It knows. Now let's check when different PCs from different VLAN are trying to ping each. Let's say PC1 is trying to ping PC number 3. PC1 is trying to ping PC number 3. Source MAC is 1111. Okay, so source MAC, sorry, source MAC is 1111. Destination MAC is 3333. Okay, PC1 sends the data. The switch reads the source MAC address. It is present in the MAC address table. Good. It reads the destination MAC address. It is also present in the MAC address table. But to forward the data, it checks, yes, destination MAC address is present in the MAC address table. I should be sending it out of interface number 3. But the receiving interface VLAN and the exit interface VLAN, both are different. The receiving interface and the exit interface VLAN, both are different. And hence, I cannot forward this data. And hence, I will not forward this data because they both are from a different VLAN. And hence, this switch is not going to forward the data at all. So the communication between PC1 and PC3 fails. Clear? Any question? Anyone? No. All right. Now let's do a quick practical about it. So practical is okay. So 0, 1, 2, 3, 4. Mm, 10.0.0.1, 10.0.0.2, 10.0.0.3, and 10.0.0.10.0.0. Let's get inside the switch. Enable. Okay. Do I have to explain you what is a user mode and what is an execution mode? Do everyone know this? स्विच में अलग अलग मोड्स होते हैं, है ना? जो मोड अभी अपन में है जिसमें where the this symbol is there, less than or equal to or whatever, like this is called as a user mode. Is everyone aware of it? User mode and execution mode. Do I have to explain this specifically? Anyone? If I have to explain, let me know. I will explain this as well. Yes, no. Yes meaning you are aware of it. No. Okay. All right. So this is how switch is. Okay. This is how a switch CLI would look like. Okay. So whenever you power on a switch, okay. Okay. First thing, let me pause this. All right. So whenever we try to connect to a switch in real world, okay, whenever we try to connect a switch to a real world, catalyst edge. So these are switch images, okay, different switch images. And if you see, does this open? Yeah. If you see, this is one of the catalyst switch, okay, one of the model of Cisco switches. So there are different Cisco switches. This is one of them. So these are the interfaces that you see, okay, where we connect the wires, where we connect different computers to them, different end devices to them. I can connect computers, laptops, or I can connect different switch to these interfaces as well using a wire, obviously. Right. And these two ports that you see are called as console ports. Console port. Now, what is a console port? So, a console port is a port through which you can log into the device, where you can connect your PC. So how it actually works is, copy. Right. So when I was explaining these connectivity, right, these PCs connected to the switch, what I am assuming is what I am assuming is one PC is connected to PC number, let's say PC number 2. This is PC number 1, and over here this is PC number 3, and this is PC number 4. This is what I am trying to explain. This is how your PCs would be connected. Okay. So now, if I have to log into the switch, okay, when I'm connecting multiple PCs on this interfaces, I will not be able to log in. No login is possible with such connectivity. With such a connectivity, no login is possible. मैं स्विच के अंदर जाके उसको कॉन्फ़िगरेशन चेंज नहीं कर सकता इसमें. To change the configurations of a switch, what I have to do is I have to connect another PC or a laptop to the console port of the switch. So you need a console cable. You need a console cable to connect to the console interface of a switch. Okay. You can connect it on your laptop through a USB. There is a USB to console port connectivity as well. There is a USB because nowadays our laptops have mostly USB ports. So USB to console cable is also present. You can use that. You can connect it to the the switch console port of a switch. Once you connect, you need to go to the control panel of the laptop. Control panel. Not control panel. Device manager. I'm sorry. Device manager. Okay. You need to go to the device manager of the laptop, and then when you connect your laptop to the console cable, it will automatically show here which which console port or communication port is it connected to, is live on your device, COM4 or COM5, etc. It will show that data. It will show that information. Now, using that information, again, you will have to open a emulator called as okay. I need to download that. Sorry. Give me a moment. Give me a moment. I'm downloading an emulator called as PuTTY. PUTTY. Most of us know what a PuTTY is. I'm pretty sure Rishikesh would also know what a PuTTY looks like. But let me just open. Okay, I do not have PuTTY installed. Okay, but however, let me show you what a PuTTY would look like. PuTTY is basically an emulator. Okay, it is basically an emulator. When we open a PuTTY, it would basically look like this. Okay, so what you need to do is you need to uh, yes, yes. This is what the PuTTY. The moment you open PuTTY, this is what the dialog box would look like. So you need to enter this particular serial. You need to click serial. Okay, you need to click serial, and then you need to mention the COM port that the device manager is showing, and just click open. Okay, serial, click on serial, okay, and mention the COM port that is highlighted on your device manager and click open. So when you do so, it will open up the CLI of the switch, which would basically look like this. This is how you basically connect a laptop or a PC to the switches console, and you will be able to see the switches CLI. Now, when the switches CLI boots up, or when the switch is powered on for the first time, you will see such kind of information. What is that information? It would basically say what is the switch model, what is the switch software version, right? And what is the switch's MAC address, and all different kind of information. These information is not relevant for us as of now. Okay. And then if you scroll down, it is showing up all the boot logs, right? And then finally, it will eventually end up with showing this prompt: switch greater than or less than symbol, whatever the symbol. This particular prompt means we are in the user execution mode. User execution mode. This is what this prompt tells: user execution mode. Now, what a user execution mode is: in user execution mode, you have limited options. Okay, you have limited options. If I press question mark, you can see I have only limited options to check on this switch. Okay, and if I even do a show and press question mark, I have only limited options of show commands that I can check on the switch. And such kind of access is given to people who we do not trust. Let's say any technical support engineer, okay, who we do not want too much of access to our switch network, we would give him this particular access: show access. Not show access, user execution mode access only. Now, to log in more, or to even go beyond this particular mode, we need to type enable. When we type enable, this gets into the privilege execution mode. Privilege execution mode. Privilege. Okay. Privilege meaning you are kind of a VIP. Okay. You have some better features. You have some better access to something. Okay. Let's say हिंदी में बोलते हैं ना VIP को privilege मिलता है. किस चीज का what privilege do they get? The VIPs. They have faster movement. Okay. They get better view, whatever, based on the environment where the VIP is sitting. That's privilege. So in privilege mode, I have more options to check the switch functions. If I do a show, I have more and many more options to check what the switch is doing. Different switch features. I can check all these features. Such features access are given. Such access is given only to a technical support team who is who is under contract of that particular customer. Okay, for example, Airtel. Airtel has a contract with, for example, Cisco engineers. So Cisco engineers will have access to this device. Any other engineer who is not under a contract with the Airtel, they will not have such access. They will have only limited access. That's the difference between user execution mode and privilege execution. All right. Now, where was I? Okay. So, as I was saying, we are assuming two things. The assumption is all the PCs know about each other's MAC addresses, and all the switches MAC address table is empty. These were our two assumptions. So show MAC address table, switches MAC address table is completely empty. Let PC1 and all the PCs know about each other's MAC addresses. For that, I will have to ping 10.0.0.2. I'm getting a reply from PC number 2. I want 3 to have the MAC addresses known. I'm receiving a reply from PC number 3. I'm receiving a reply from PC number 4 as well. Let me ping 2, 3, 4 as well. Ping 10.0.0.3. 3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0.0.3. 10.0 ping 10.0.0.4. Now that's all, and let's ping 3 and 4 as well. Ping 10.0.0. So now all the PCs know about each other's MAC address. So first assumption is correct. Our first assumption is now true. Then the second assumption that the switch's MAC address table should be empty. So let me clear the MAC address table. MAC address table. Now if I do a show, the MAC address table of the switch is empty. Now let me add VLANs to the switch. Okay. So to add VLANs to the switch, I hope I do not have to explain what a configuration terminal is to anyone. How to access configuration terminal. Does everyone know this? Rishikesh? You would know all this, right? Yes, no? Okay. So I'm assuming, since no one has answered, so I'm assuming yes, everyone knows it. Now, configuration terminal helps us to get inside the configuration mode of the switch where I can configure configuration terminal. Okay. Now, what I said, VLANs are configured on the switch interfaces. Okay. The devices that are connected to the switch interface are not part of that VLAN. So PC1 is not part of VLAN number 10, but interface 0/1 of the switch is part of VLAN number 10, not the PC. Okay. So as I said, we have to be very careful about our words. As I said, when we explain PC1 is part of VLAN number 10. No, PC1 is not part of VLAN number 10. PC is connected to a switch interface. That switch interface is part of VLAN number 10. Okay. So interface pass Ethernet 0/1. Now, there are two modes. One is an access mode. The other is a trunk mode. I will explain about this access mode and trunk mode later. Okay, probably in today's session, later in the session, I will explain about access mode and trunk. Okay. So how to configure this is we will type switch port mode access. Okay. I am changing the mode. As I said, do not worry about this. What is this mode? Access mode, trunk mode. I will explain that later. But what I'm telling the switch is this switch port, the mode of this switch port is access. Simple. Okay. And the next is switch port access VLAN 10. So you can clearly see this interface now turns orange and is now part of VLAN number 10. Okay. So let me show you the VLAN. Show VLAN. When I do a show VLAN, you can see all the other interfaces. Yeah, one more thing. On a Cisco switch, by default, all the switch interfaces are part of VLAN number 1. VLAN number 1 is configured by default. This is, you cannot delete this. You cannot change this. And all the switch interfaces by default are part of VLAN number 1. Okay. So now we created VLAN number 10 and we added 0/1 to be a part of VLAN number 10. We can see this with the show VLAN command. Show VLAN command gives us VLAN number 10. Shows us VLAN number 10 and 0/1 is part of VLAN number 10. Okay. Then the other interface, PC number 2 interface, that is 0/2. It is also part of VLAN number 10. So configuration terminal, interface fast Ethernet 0/2, switch port mode access, switch port access VLAN 10. All right. So now we will see two interfaces being a part of VLAN number 10, 0/1, 0/2. Earlier, 0/2 was part of VLAN number 1. As I said, all the interfaces are by default part of VLAN number 1. But when I specifically configured 0/2 to be a part of VLAN number 10, we can see that result over here is part of VLAN number 10. Right? Then 3 and 4 are part of VLAN number 20. Okay. 3 and 4 are part of VLAN number 20. So configuration terminal. Now instead of configuring individual interfaces, I can configure a range of interfaces which are part of a similar VLAN. So interface range fast Ethernet 0/3-4. Interface 0/3 and 0/4. Because the configuration on both the interfaces is going to be same, I don't have to specifically or exclusively configure VLAN 20 on both the interfaces separately. I can configure as a group. So for that, interface range fast Ethernet 0/3-4. Switch port, I can just simply write access VLAN 20. What does this do? This basically removes two configurations. One is this one, switch port mode access, then switch port mode access VLAN 10. I'm directly writing it as switch port access VLAN 10. Basically, I'm telling the switch ports that you have the mode, your mode is access, and you will be part of VLAN 20. Simple. I am ignoring the first line, switch port mode access. I do not have to write that exclusively. I can just simply write switch port access VLAN 20 and it will still work. It said 20 does not exist. 20 VLAN was not created. So it is creating VLAN 20. And these two interfaces are now part of VLAN number 20. So let's just verify this. Show VLAN. So you can see 0/3 and 0/4 are part of VLAN number 20. All right. Now, let them come up. Okay. If you guys have any question with the configuration also, let me know. Let's say that you did not understand a particular configuration. What is it doing? Ask me, I will let you know. But till now, any question with the configuration? Simple configuration, right? Now, let us ping PC1 to PC number 2. Ping 10.0.0.2. Okay. So over here, you can see PC1 created a packet. Okay, let me just first go from a real time perspective. PC number 1, we are receiving a response from PC number 2. Okay, let me ping PC number 3. We will see we are not receiving a response from PC number 3. It says request time. It will try to ping multiple times, but we will not see a response. The same result we will see with PC number 4 as well. Okay. PC number 4 as well, we would see the same result, where PC1 is unable to ping PC number 4. Okay. Now, let me again remove the MAC address of switch. Clear MAC address. Okay. So there is no MAC entry. Now again, let me try to ping PC1 and PC2 and let me show you what actually happened. Ping PC number 2. So PC number 1 created a packet. Okay. So PC1 created a packet and we are concentrating only on the Ethernet header. We are not concentrating on IPv4. We are concentrating only on layer 2 as of now. So 44B2 is the destination MAC address. Source MAC address is 7231. 7231 44B2. Okay. PC1 sends the data to switch. Switch reads the source MAC address, right? Switch reads the source MAC address and it makes an entry. When it makes an entry, it will make an entry for MAC address, on which interface was it received, and the VLAN. So show MAC address table. 7231 is the source MAC address. Which interface was it received on? And this interface is part of which VLAN? That is VLAN number 10. Okay. Then it checks the destination MAC address. 44B2. Is 44B2 present in the MAC address table? No. 44B2 is not present in the MAC address table. And when the MAC address is not in the MAC address table, what does the switch do? It will broadcast it. Correct? But here, does the switch broadcast to 3 and 4? Let's check. See here. It did not broadcast to 3 and 4. Why? Because the receiving interface was of VLAN number 10. And the switch checks show VLAN. Which are the other interfaces that are part of VLAN number 10? In our topology, there's only one interface which is part of VLAN number 10, that is 0/2. And hence, the broadcast is also only on that interface, that is 0/2. 3 and 4 do not belong to VLAN number 10. They belong to VLAN number 20. That is why the packet was not broadcasted out of those interfaces. It was broadcasted only to 0/2. And this packet then reaches PC number 2. Obviously, the MAC address belongs to PC number 2, so PC number 2 responds. PC number 2 responds. When PC2 number 2 responds, 7231, which is the destination MAC of PC number 1. 44B2 is the source MAC of PC number 2. PC2 responds. The switch receives it. When the switch receives it, it makes a note of the source MAC address. So 44B2 was received on 0/2, and the interface VLAN is VLAN number 10. Okay. The destination is 7231. Okay. Do I know how to forward it? Yes, it should be forwarded out of 0/1. But is the receiving interface VLAN and the exit interface VLAN, are they same? Yes, both are same. So the criteria matches. The receiving interface VLAN and the exit interface VLAN, the criteria matches, and hence I can forward it out of 0/1. So the PC forwards it out of 0/1 and it reaches PC number 1. Okay. Any question with this flow? Any question with this flow? Okay. Now, let's try to ping PC1 and PC3. Okay. So PC1 creates a packet. It has a source MAC address and it also has a destination MAC address. Source MAC address is 7231. Destination MAC is 58E8. Okay. The PC forwards the data. It is received by switch. Switch makes an checks for the source MAC address. Is the source MAC address present? 7231 is already present. So that's okay. The receiving interface is VLAN 10, 0/1. Then it checks the destination MAC address. What's the destination MAC address? Destination MAC address is 58E8. is 58E8 in the MAC address table of the switch? 58E8 is not there in the MAC address table of the switch. And when the MAC address is not present in the MAC table, it broadcasts. But here again, the incoming interface VLAN is VLAN number 10. When the incoming interface VLAN is VLAN number 10, the broadcast will also be on those interfaces which belong to VLAN number 10, that is 0/2. So the data is sent to PC number 2, but the MAC address, the destination MAC address 58E8 is not of PC number 2. That is why PC number 2 drops it. PC3, PC4 never receive it because they do not belong to VLAN number 10. They belong to VLAN number 20. And hence, we would see a request timeout. We will never see a response from PC number 3 because the broadcast, okay, never reached PC number 3. It never reached PC number 3. That is why it never even replied. Okay, the same kind of criteria goes for PC number 3 and PC number 4. Let me ping PC number 3 and PC number 4 real quick. I hope I don't have to explain the process because PC3 and PC4, they both belong to the same VLAN interfaces. I'm sorry. The switch interfaces that is connected to PC3 and PC4, they belong to the same VLAN, and PC3 and PC4 will be able to ping. Switch will read their MAC addresses and it will populate. Ping 10.0.0.4. I'm receiving the reply. Now, switch 1 will have the MAC addresses of all the PCs. It has the MAC addresses of all the PCs. Okay. Now, let me ping PC1 and PC4. PC1 and PC4, and let's see what happens. Is there any question how PC3 and PC4 are able to ping? Anyone? It's the same process, how PC1 and 2 were able to ping. Same thing, PC3 and PC4. Any question there? No. So let me ping PC1 and PC4. Okay. So destination is D5VE and the source is 7231. The data is sent to switch. Switch already knows the source MAC address 7231. Okay. The destination MAC is D5VE. The switch knows how to forward the data to D5VE, that is 0/4 interface. But the incoming receiving interface and the exit interface VLAN are different. The receiving interface VLAN is 10. The exit interface VLAN is 20. That is why PC number 1 will never be able to send the data to PC number 4. So over here, if you see, it sends the data to PC number 2. Okay, it sends the data to PC number 2 because they both belong to the same VLAN. But PC2 never forwards, never basically accepts. Simple. That is why in real time, we will never see a response from PC number 4 and we will see a request timeout as well. Clear? Any question? Anyone? Question? Now, what if there are multiple switches involved? So you have switch number 1. You have another switch number 2. Okay. These two are connected. This PC number 1, PC number 2, PC number 3, and PC number 4. Okay. PC number 1 on switch number 1 is connected to VLAN 10. This is 20. This is 10. This is 20. Okay. In such a scenario, now, in such a scenario, if I want PC1 and PC3 to communicate, if I want PC1 and PC3 to communicate, what I will have to do is that I will have to the same way what I configured for this interface just now. I will have to do a same configuration of this interface as well. Let's say that interface is interface number 1, interface number 2, interface number 1, interface number 2, interface number 3. Okay, and similarly on switch number 2, interface number 3, I will have to configure VLAN 10 over here. So now what would happen? PC1 and PC3 can communicate. Number 1 and PC number 3 can communicate. However, that brings a problem. The problem is if PC2 and PC4 they want to communicate, it will not be possible because when PC2 sends the data, which already knows these two are different interfaces, interface VLAN, and hence it will not forward the data. So PC2 and PC4 will not be able to communicate. To make them communicate, I will have to again change the VLAN between the switches, which that is VLAN 20. With this, what will happen? PC2 and PC4 will be able to communicate. But again, the problem comes, PC1 and PC3 will not be able to communicate because when PC1 sends the data or PC3 sends the data, it automatically knows the receiving interface and the exit interface are of two different VLAN, and hence it will not forward the data. Okay. So for this, what was the solution? The solution was to bring up a mechanism where I can add multiple VLANs on a single interface. Till now, we saw on this switch, when we were dealing with one single switch like this, I was just configuring one single VLAN on these two interfaces. VLAN 10 over here, VLAN 10 over here, VLAN 20 over here, VLAN 20 over here. But when you have multiple switches involved, where on different switches you have the same VLANs configured, like here you have VLAN 10 on one switch, here you have VLAN 10 on another switch. They both need to communicate. So in such a scenario, you need that these two switches have both the VLANs configured on their connecting interface. So we can configure multiple VLANs on these two interfaces. And to configure multiple VLANs on these two interfaces is we call as trunk configuration or trunk port. We call it as trunk port. Okay. Configuring multiple VLANs on a single switch interface is called as trunking. Configuring one single VLAN on a switch interface is called as access. Simple. Access means one VLAN. Trunk means multiple VLANs. Multiple VLANs. All right. Now, let's take a break of 15 minutes. We will resume the session at 12 p.m. There, I will explain what is trunk, what is access with these two switch kind of configuration. We'll first read the theory, and then we will understand the through the lab. All right. So let's come back at 12 p.m. But before that, any questions? Any questions? No? All right. So to have multiple VLANs across switches, talk to each other, we need a trunk interface between the switches. Okay, we need a trunk interface between the switches. Then only multiple VLAN interfaces on different switches can communicate with each other. So Let's say, as I said, we have configured trunk. How to configure trunk? I will also let you know that. So we have configured trunk VLAN 10 and 20 on interface number 3 of switch number 1, and VLAN 10 or 20 on interface number 3 of switch number 2. Okay. Now let's take the same example where PC1 is trying to send data to PC number 3. Source MAC is 1111. Okay. Destination MAC is 3333. Okay. Again, the same thing. You have VLAN, then you have MAC address, and then you have interface column. Okay. This is the MAC address table of switch number 1. Similarly, you have VLAN, MAC, and interface number of switch number 2. Okay. Now, PC1 sends data. The switch receives it. It reads the source MAC address 1111. It makes an entry for it. It makes an entry for it. Which interface was it received on? Interface number 10. And this interface number 1 belongs to which VLAN? VLAN number 10. Okay. Okay. So it belongs to VLAN number 10. Right. Then it checks the destination MAC address. The destination MAC address is not present in the MAC address table. When the destination MAC address is not present in the MAC address table, it checks for other interfaces which are part of VLAN number 10. This does not belong to VLAN number 10. However, this interface, VLAN number 3, is part of VLAN number 10 as well. That is why the switch now forwards the data out of that interface. It will forward the data out of this interface. Okay. Now, switch number 2 receives it. Switch number 2 will make an entry for it. Source MAC address 1111. It was received on interface number 3. To which VLAN does it belong to? VLAN number 10. All right. Then it checks the destination MAC address. It checks the destination MAC address. Then it sees the destination MAC address is not present in the MAC address table, right? So it broadcasts. When it broadcasts it, it will check which is the exit interface, which is also part of VLAN number 10. And hence, this is the only interface. So PC number 3 receives it. All right. Now, when PC3 responds, PC3 source MAC addresses 3333, destination MAC is 1111. Okay. PC3 responds, switch 2 receives it. It will make an entry for the source MAC address. 3333 was received on interface number 1 and it belongs to interface number 10. Good. Then it checks the destination MAC address. Does it know the destination MAC address? Yes. Out of which interface should it send? Interface number 3. Is the receiving interface and the exit interface from the same VLAN? Yes, they belong to the same VLAN. And it will forward the data to switch number 1. Switch number 1 will receive the data. It will check the source MAC address. It will make an entry for it. 3333 was received on interface number 3. And to which VLAN does it belong to? VLAN number 10. It then checks the destination MAC address. Okay. The destination MAC address is present in the MAC address table. Out of which interface should it send? VLAN interface number 1. But is the receiving interface and the exit interface, are they both from the same VLAN? Yes, they both are from the same VLAN. And it will forward it to PC number 1. Okay. Any question with the flow? Any question with the flow over here? No question? All right. If you guys have no question, let me ask you guys. Okay. When switch 1, when switch 1 is sending this data, or when switch 2 is sending this data, okay. Let's say switch 1 sends the data to switch number 2. I said when switch 1 sends the data to switch 2 will make an entry for it. It will say 1111 was received on source MAC of 1111 was received on interface number 3. To which VLAN does it belong to? VLAN number 10. Now the question is, how does switch number 2 know that the incoming data? How does the switch number 2 know that the incoming data belongs to VLAN number 10? क्वेश्चन ये है कि स्विच 2 को कैसे पता पड़ा कि भाई इनकमिंग डेटा जो है VLAN 10 से है. सिमिलरली स्विच 2 ने जब डेटा भेजा, when switch 2 sends the data, how does switch 1 know that the incoming data is of VLAN number 10? This is the question. Can someone answer? How does the switch know what VLAN does the data belong to? Interface. Someone is saying interface. Okay. Anyone else? Okay. So someone said interface. Right. Someone said interface. But on this interface, there are two VLANs, VLAN 10 and VLAN 20. How does the switch 2 know which VLAN does it belong to, VLAN 10 or VLAN 20? Because there are two VLANs. It was not single VLAN. There are two VLANs, or in real time there may be multiple VLANs. How does the switch 2 knows if it belongs to VLAN 10 or VLAN 20? Similarly, how does switch 1 know if it belongs to VLAN 10 or VLAN 20? Right. So someone has answered it correctly on the chat. It is VLAN tag. It is VLAN tag. All right. Now, here is the concept. On a trunk interface, when you have two switches connected via trunk interface and you have multiple VLANs configured on that interface, let's say 10 and 20. So when the first time the switch sends this data to switch number 2, it adds the source MAC address. Obviously, there's a source MAC address, there's a destination MAC address, and also a VLAN ID. VLAN ID of 10. It adds a VLAN ID of 10. And this is only true when you have a trunk interface. We saw an access interface configuration. On an access interface, when there is only one VLAN involved, there will be no VLAN tagging. Understand this concept. On an access mode interface, there will be no VLAN tags or VLAN IDs. But on a trunk interface, when the switch is sending the data, it will add the VLAN ID. Now, the second question. Which VLAN ID should it add? कौन सा VLAN ID को उसे add करना चाहिए? ये switch को कैसे पता पड़ेगा? Which VLAN ID to add? How does the switch know this? Should it add VLAN 10 or should it add VLAN 20? How does it know? Second question. Any guess? VLAN 20, why would it add VLAN 20? The data is for VLAN 10, right? Why would it add VLAN 10, VLAN 20? Okay. So the switch knows which VLAN to add by looking at the receiving interface VLAN. The receiving interface VLAN is 10, and hence when I'm sending this data out of the trunk interface, I will add VLAN number 10 to the data. I will add VLAN number 10 to the data. Clear? This is how the switch knows which VLAN to add on the data. Should it add VLAN 10 or should it add VLAN 20? ये उसको कैसे पता पड़ता है? जो इनकमिंग इंटरफेस है, रिसीविंग इंटरफेस है, उस पे जो VLAN लगा है, इस पे VLAN, ये रिसीविंग इंटरफेस VLAN 10 का पार्ट है. इस वजह से ट्रंक इंटरफेस से जब वो डेटा आगे भेजेगा तो उसमें VLAN 10 लगाएगा. अगर ये डेटा 20 वाले VLAN 20 वाले रिसीविंग इंटरफेस का था तो आउटगोइंग इंटरफेस ट्रंक पे आउटगोइंग सॉरी ट्रंक पे जो डेटा जाएगा उस पे VLAN 20 लगेगा. तो everything is decided based on the receiving interface. Okay. So over here, when the switch is forwarding this data, it will add a VLAN tag or VLAN ID of VLAN number 10. That is why when the switch number 2 receives it, it will make an entry for it, saying 1111 was received on interface number 3 and it belongs to VLAN number 10. Then it checks the destination MAC address 3333, which is not present in the MAC address table. When it is not present in the MAC address table, it will forward the data out of all those interfaces which are part of VLAN number 10. Clear? Any question? No. All right. Now let's say what will happen. What will happen if VLAN 20 devices are talking to each other? So PC2 sends the data. The switch makes an entry for it. And which VLAN was it? It is VLAN 20. Okay. Now it checks the destination MAC address. PC2 is sending data to PC4. 22224444. Is 4444 present in the MAC address table? No. So it needs to forward this data, but it will forward the data out of only this interface because this interface is the only interface that also belongs to VLAN number 20. So when it is forwarding the data, it will add VLAN ID of 20 and it will forward it to switch number 3. Switch number 2. When switch 2 receives it, it will check the source MAC address 2222 and it was received on interface number 3 and it belongs to which which VLAN? 20 VLAN. Okay. Then it checks the destination MAC address. The destination MAC address is not present in the MAC address table and hence it needs to forward it or broadcast it. But it will broadcast it out of only those interfaces which belong to the same VLAN. That is why it will forward it to TP number 4. Clear? Any question with the flow? Any question with the flow? No question? All right. Now, let's quickly do a practical for it. Guys, can you hear a lot of background noise? Just let me know. Because I am wearing a headphone, so and it's also a noise cancellation, so I'm not sure if you guys can hear a lot of background noise. I'm not sure. Just let me know. Okay, how many guys? How many of you have worked with, worked on or practiced on Cisco Packet Tracer? Have you guys worked on Cisco Packet Tracer? Worked meaning practice. Yes, Praful says. Rishi, Pesh, and Abhishek, have you guys practiced on Cisco Packet Tracer? No. Okay, you are not practiced on Cisco. Okay. So, Abhishek and Rishikesh, is this the first time you're looking at Packet Tracer? Should I explain how to work on it? Okay. So, Cisco Packet Tracer. Cisco Packet Tracer is a free downloadable software created by Cisco, obviously. Okay. All you need to do is just go to Cisco, just search Cisco Packet Tracer, download. Okay. Just say Cisco Packet Tracer download and check this particular link, download Packet Tracer link. Okay, click on this link. Okay, it will open up a community page. Click this hyperlink. It will take you to the Cisco learning page. Here, what you need to do is you need to create an account for yourself first. You need to create an account and you need to learn or you need to start this particular course. It's free. There's no need to pay for this course. It's free. And once you start, okay, let me show you how to start this course. Give me a minute. So once you log in, once you create an account, you need to start this particular course, getting started with Cisco Packet Tracer. Okay. And when you start, okay, in the first module itself, there is a in the first module, there is a chapter called as download Cisco Packet. Okay. Just download the file, install it. Okay. After you install it, the the Cisco Packet Tracer would look like this. Okay. Now, Cisco Packet Tracer, this is how the homepage or the opening page of the Cisco Packet Tracer looks like. And there are two workspaces. I'm only telling you what is important for you to learn. I'm not telling you every detail of Cisco Packet Tracer. You just need to know few things about Cisco Packet Tracer with which you can practice. There are two workspaces on your Cisco Packet Tracer. One is a real-time workspace. The other is a simulation workspace. In real time, it basically shows you result in real time. Let's say if you try to ping, if you ping 1.1.1.1 to 2.2.2, it will simply show you a reply getting. You are getting a reply, you are getting a response. Okay. But if you move it to a simulation mode, okay, the way I just showed you what kind of packet is sent by the PC, it was in an envelope form. You can open the envelope, you can see the data inside, what is the data that is being sent, how the switch is processing it, etc. All that information you can see it in the simulation mode. So there are two modes, real time and simulation. Okay. So with real time, you can just simply practice. Okay. And if you want to literally know what is going on inside the data, you switch to the simulation. Okay. Then at the bottom, you can see there are a lot of devices. Okay, so here you have networking devices, end devices, components, cables, miscellaneous multi-user connections. Okay. So if you click on the networking devices, you can see there are routers. If I click on routers, you can see there are different routers. Okay, you can use any router to practice. If I click on switches, you can see multiple switches. If you click on hubs, you can see hubs, wireless devices, security devices, and WAN emulators. If you click on end devices, you can see end devices like PC, laptop, server, etc. that you can do. So to create a topology, all you need to do is just drag and simply drop it. Okay. Now, once you drag and drop with cables, I usually use this bolt symbol cable because you can see it writes automatically choose the connection type. Okay, I prefer this. Let the tool choose what the connection type should be. Okay, so I just simply drag and drop these devices, and with the cable, I just click over here and click over here. It just connects the two ends. Simple. And you get a topology. All right. Very simple. Nothing much. All right. Now, moving on with our discussion. Yeah. So what I will do is I will configure. Okay. So what I'm doing here is okay. So what I will do is I will configure this interface 0/3 of switch number 1 for VLAN number 10, and 0/2 of this switch as VLAN number 10, 0/2, 0/3 of switch 1 and switch 2 to be VLAN 20, and the interfaces between to be of trunk interfaces. This is what I'm going to do. So switch number 1, okay, switch number 1, enable configuration terminal, interface fast Ethernet 0/3, 0/3, interface fast Ethernet 0/3. Okay, I have not created VLAN. Okay, I can just create VLAN by simply writing this particular configuration: switch port, access, VLAN 10. So here what I'm doing is I'm skipping two parts. I'm skipping the part where I have to exclusively configure VLAN 10. That's one additional step. Then switch port mode access. That's the second additional step. So I'm skipping these two steps and I'm configuring VLAN 10, and I'm also configuring this switch port as access in one single line. Switch port access VLAN 10. Okay, that's one. Second thing, exit. So what I was trying to skip is VLAN 20. With this, I will create VLAN 20. Okay, then interface fast Ethernet 0/2 on switch number 1, switch port mode access. This particular line. So these two lines, VLAN 20 and switch port mode access, I have completely skipped these two lines and used one single line to achieve these two parameters. I said this particular switch port is access and part of VLAN 10. So it automatically created VLAN 10 and also made this particular port as an access. So I skipped two extra lines of configuration, right? Switch port, access, VLAN 20. So let me check, show VLAN. Show VLAN, and we will see VLAN 10, VLAN 20 being configured on 0/3 and 0/2. All right. Now 0/1 interface of switch number 1. I need it to be configured as trunk. Configuration terminal, interface fast Ethernet 0/1, switch port mode trunk. Okay, I change the configuration to switch port mode trunk, meaning that I will be allowing not just one VLAN, I will allow multiple VLANs on this trunk. Okay, so switch port trunk allowed VLAN 1, 10, and 20. Okay, so I have allowed VLAN number 1, VLAN number 10, and VLAN number 20 because show VLAN. We know that by default, all these switch interfaces are part of VLAN number 1. So I have allowed VLAN number 1. I have allowed VLAN number 10 and VLAN number 20, both the VLANs. A similar configuration I would do on switch number 2 as well. Configuration terminal, interface fast Ethernet 0/2, which is PC7. I will be configuring that interface as VLAN 10. Switch port, mode, access, VLAN 10. Sorry, not switch port. Switch port, access, VLAN 10. Simple. Okay. Then interface fast Ethernet 0/3. Switch port, access, VLAN 20. Right. Then interface fast Ethernet 0/1. Switch port, mode, trunk, switch port, trunk, allowed, VLAN 1, 10, and 20. Okay. Any question with the configuration? Anyone has any question with the configuration? Any problem understanding the configuration, or do you want me to repeat a configuration, or do you want me to explain a particular configuration? Anyone? No? All right. Now, let's do the same thing where all the PCs know about each other's MAC addresses. Okay, no problem. Okay. The switches MAC address table are empty. That's the only assumption that we were going to make. So, if I do a show MAC address table, okay, I've not configured any IPs to the PC. Desktop 10.0.0.5. This is 10.0.0.6. 10.0.0.6. Okay, yeah. So if you want to configure IP addresses on PCs, just click PC. Okay, it will open this kind of a dialog box. Okay, so you can see there are multiple tabs. If you click on PC, so you can see there are like it basically tells the on this particular PC what are the different slots that you have on this particular PC's what do you say CPU. These are basically it's not important. Configuration again not important. Okay. Desktop, we will go to desktop tab, and where we can configure IP addresses, IP configuration. So I will configure on PC number 7 10.0.0.7. And the moment I do so and just click here, it automatically chooses the subnet mask. Okay. About IPv4 addressing and subnet mask, we will talk later when we are discussing IPv4. Not now. Just understand the moment you write an IP address, it automatically chooses the subnet ID or subnet mask for that. Okay. And the MAC address of the PC ends with 855. Okay. This is the MAC address 000196B6855. This is the MAC address of that interface. All right. So we will only remember the last one 8553 for PC number 7. Okay. Similarly, you can configure on PC number 8, going to desktop, IP configuration 10.0.0.8. Done. Okay. So now let me ping PC number 5 and PC number 7. All right. So if I ping PC number 5 and PC number 7, to ping, I will have to go to the command prompt of this PC. Okay. So ping 10.0.0.7. Okay, and we will see a response in question and out. We will see a response. If not, let's troubleshoot. Why? Let's troubleshoot why did it not work. So switch number 1, show interfaces trunk on fast Ethernet 0/1 strung. VLAN 1, VLAN 10, VLAN 20 is allowed. Okay, then show VLAN on 0/3 we have VLAN number 10, and on VLAN number 0/1 we have VLAN 1, VLAN 10, VLAN 20 allowed as well. It goes to switch. Let's go to switch number 2. Show interfaces trunk to check which interface do you have trunk allowed on, and you can clearly see on this particular interface of switch I have not allowed VLAN 10, but I VLAN 20 because I did not allow VLAN 10. That is why switch number 2 does not accept the packet. Okay, let's check that. Why does it not accept the packet? So let me ping again from PC number 5 to PC number 7. Okay, so the PC number 5 created a packet. This packet is basically an ARP packet. Okay, I'll talk about ARP later. Anyhow, so switch number 1 receives it. It is received on VLAN 10 interface. It checks which is the other VLAN interface which has VLAN 10, that is 0/2. So now if you see here, when I open the packet, this is the receiving packet and this is the outgoing packet. Okay. Now in the receiving packet, you will see you have a source MAC address, and this is an ARP packet. I hope everyone knows what an ARP is, but we will discuss ARP in a lot of detail later. Okay, but over here our main concern is VLAN. Over here the incoming packet from PC number 5 does not have any VLANs added, and this proves my point. PCs, end devices like laptops, PCs, printers, servers, IP phone, IPTV, they do not understand VLAN, and hence you will not see a VLAN ID over here. But when the switch is forwarding it out of which interface 0/1, you will see a VLAN tag. TCI. TCI stands for Tag Control Identifier. Tag Control Identifier. It says A. Shouldn't it be 10? Why is it A? It is because the A is in the hexadecimal format. This 10 hexadecimal format is A. That is why it is mentioned as A. It has been mentioned as A. So VLAN tag is present there. VLAN tag is there on the outgoing packet or outgoing side of the packet, VLAN 10. So you can see VLAN tag being added. This data goes to switch number 3, and switch number 3 does not have VLAN 10 allowed on the trunk. It sees a data, see here, it sees a data which has a tag of VLAN number 10. But on this trunk interface, there is no VLAN 10 allowed. And that is why the data gets dropped. The data is not forwarded. And hence we are seeing a request timed out on PC number 4. Any question with this flow? Anyone? Any question? No. Now, let me change the configuration on PC number 3. Configuration terminal, interface fast Ethernet 0/1, switch port, trunk, allowed, VLAN, add 10. Okay. And okay. Now, why did I use the command add 10? Why couldn't I just write interface fast Ethernet 0 configuration terminal interface fast Ethernet 0/1 switch port trunk allowed VLAN 10. Now, could you guys guess what is the difference between this command and this command? VLAN add 10 and VLAN 10 command on the trunk command line. On this switch port, which is a trunk port, allow VLAN 10. On this switch port, which is a trunk port, allowed VLAN add 10. What is the difference between these two command lines? Can someone tell me? And if you guys are on LinkedIn, you may have seen a meme regarding this. VLAN add 10 meme. No guesses? All right. The difference is if I just add switch trunk, switch port trunk allowed VLAN 10, what will happen? Earlier, what were the allowed VLANs on the trunk? 1 and 20, correct? It was 1 and 20. Now, after I configured this command, switch port trunk allowed VLAN, let's see what happens. So show interfaces trunk. You will see 1 and 20 are now removed. It has been overwritten by 10. Now only 10 VLAN will be allowed. Now VLAN 10 only will be allowed. 1 and 20, which were earlier allowed, have been replaced by 10. If I use this command, allowed VLAN 10, it basically deletes every other VLAN and only 10 is allowed. That is why it is extremely important to use the command line add or to to the prompt as add configuration terminal interface fast Ethernet 0/. Configuration terminal interface fast Ethernet 0/1 switch port trunk allowed VLAN add 1, 20. Oh, I can add only 1 by 1. Switch port trunk allowed VLAN. Then okay. Then now let's check switch port show interfaces trunk. Now you will see all 3 VLANs being added. Clear? Now let's first look at this particular model. Since we are into CCNP and CCIE, we should understand the table, what's there in the table. This is not a CCNA class. This is a CCNP plus CCIE. So we should understand the information present in the table as well. So to see the trunk ports, we have to use this command, show interfaces trunk. Which is the trunk interface? Fast Ethernet 0/1. Trunk mode is on. Encapsulation dot 80.1q. 80.1q encapsulation. What does this mean? This is the IEEE name for VLAN. We are encapsulating the data. We are encapsulating the data into a VLAN ID. And that VLAN ID's IEEE name or IEEE standard is 802.1q. 0/1 status is trunking. The native VLAN is on this particular trunk is 1. I will explain native VLAN in just a while. Not now, in just a while. 0/1, the native VLAN is 1. Okay. On this particular interface, what are the VLANs that are allowed? 1, 10, and 20. Okay. On that particular interface, which are the management domain. I'll talk about management domain later, but in the management domain, which are the okay, VLANs in spanning tree forwarding state and not true. This is the only, we'll talk about spanning tree when we are talking about spanning. So, what is the port? Guys, can you hear my voice? Can you see my video and can you see my screen? Okay, thanks. So 0/1 mode is on, 802.1q VLAN trunking, and native VLAN is 1. Okay. So now when I ping PC number 5 to PC number 7, now I should see a packet. Why is there a request timeout even now? What's up? Mhm. So I didn't add VLAN 10 over here. Okay. Why? Configuration terminal, interface, fast Ethernet 0/2, fast Ethernet 0/2, switch port access VLAN 10, show VLAN 0/2, 0/3 is VLAN 20. Configuration terminal interface fast Ethernet 0/3, switch port access VLAN 20. So, yeah, Praful, you're right. I did not configure correct VLANs on these two interfaces. That's why the PCs were not able to ping. I hopefully believe it should be able to ping now. Let's wait. PC5, fine. Okay. So we are receiving a response from PC7. Now, how is this working? Let's check. So on PC number 5, I did a ping. So a packet is created with the MAC address, destination MAC address of PC7, source MAC address of PC number 5, right? The data is forwarded to switch number 1. Switch number 1 makes an entry for it. Okay. So show MAC address table. Okay. So A202 was received on 0/3. Okay. Then the destination MAC address is 8553. Okay. 8553. 8553. First of all, let me clear the MAC address. Let me clear the MAC address table and let me show you one second. Clear MAC address here as well. Here, okay. So PC number 5 sends the data with its own source MAC address and its destination MAC address is 8553. So the switch receives it. Okay. Switch will make an entry that show MAC address table, that this particular MAC address was received on 0/3 and it was received on my access VLAN interface, VLAN number 10. Now, the destination MAC address of 8553, is it present in the MAC address table? No, it is not present in the MAC address table. And if it is not present in the MAC address table, which are the other interfaces that belong to the receiving interface VLAN? So let me check. Show VLAN, which are the other interfaces. Okay, that is this interface only. But this is the incoming interface. Are there any other interfaces as well? So let me check. Show interfaces trunk as well. Yes, there is a trunk port, which is 0/1. And on that interface, 10 VLAN is allowed. So I can use this trunk port to send this data. Okay. So when it is sending the data, see the received packet. Inbound means the received packet. There is no mention of VLAN number 10. But in the outbound packet, there is the mention of VLAN number 10. And this is what we call it as VLAN tagging, VLAN ID addition. Okay. So to a normal Ethernet data or a data frame link, it is adding a VLAN ID of VLAN 10. So switch 2 receives it. It will make an entry. Show MAC address table. It made an entry that I cleared the MAC address table. Yeah. Okay. This is from switch. This is from the switch, the nearby switch. Okay. Leave these. Leave the first, third, and fourth line. Just concentrate on this. This is A20D, which is the MAC address of PC number 1. It made an entry. Okay. It was received on 0/1. And to which VLAN does it belong? VLAN 10. How did this switch know that it belongs to VLAN number 10? By reading the VLAN tag on the incoming packet. By reading the VLAN tag on the incoming packet. Now, when it needs to forward the data to destination 85553, is 8553 present in the MAC address table? 8553, as we saw, is not present in the MAC address table. And when it is not present in the MAC address table, it needs to broadcast. But it will broadcast only out of those interfaces that are part of VLAN number 10. So, show VLAN. This interface 0/2 is the other interface which is part of VLAN number 10, and hence I will forward the data out of this interface and it will reach PC7. Right? PC7 accepts it. Any question with this flow? What with this one directional flow? Any question? No? All right. PC7 accepts the data, and you see here, when PC7 is accepting the data, or even let me show you this. When the switch is forwarding the data, you see here in the inbound, the data that it received, it had a VLAN ID. But the data that it is sending to the PC, it is removing the VLAN ID. It is removing the VLAN ID. Why is it removing the VLAN ID? Why can't it keep the VLAN ID? मेरा क्वेश्चन ये है, जब स्विच को रिसीव हुआ था VLAN 10, स्विच को VLAN टैग लग के रिसीव हुआ था, बट जब स्विच उसको आगे भेज रहा है तो वहां से VLAN ID रिमूव कर रहा है. Why? Any guess? Anyone? Correct. Access port. So, because it is an access port, it will remove the VLAN. I mentioned on an access port, you cannot have a VLAN tag. Only on trunk interfaces, you will have a VLAN ID or a VLAN tag. Because this interface is an access mode, it will not add any VLAN to it. Before sending it out of that access interface, it removes the VLAN. Do not think that this is connected to PC. That is why it is removing the VLAN. ये मत सोचना कि ये पीसी से कनेक्टेड है, इस वजह से यहाँ से वो VLAN हटा रहा है. नहीं, मैंने बताया था पीसी को, स्विच को नहीं पता. Switch does not know that if this connection is to a PC, is it to a switch, is it to a server, is it to any other networking device? It does not know. स्विच को ये नहीं पता कि भाई मेरे सामने इस इंटरफेस पे क्या कनेक्टेड है, उसको नहीं पता. उसको सिर्फ ये पता है this interface is an access interface, and on an access interface I cannot tag it. Even when I'm receiving a tag, even if I'm receiving a data or if I'm sending a data, I cannot add a tag. That is why it removes the tag. It removes the tag. And when it removes the tag, it will send the data without a tag to PC. Okay. So PC receives it, PC7 receives it. Okay. And PC7 responds. When PC7 responds, the switch will receive it. Switch will make an entry for the source MAC address. Show MAC address table. Okay. Source MAC address was received on 0/2. So 0/8553. It was received on 0/2, and this interface is part of which VLAN? VLAN number 10. Okay, then the destination MAC address of A20D. Do I know it? Yes, I already know destination MAC address. It is part of 0/1. And is the incoming interface and the exit interface, are they both of the same VLAN? Yes, they both are from the same VLAN, and hence I can send the data. But when I'm sending the data, since it is out of a trunk interface, I will add a VLAN tag of 10. I will add a VLAN tag of 10 to it. Okay, मतलब स्विच ने देखा कि भाई मेरा इनकमिंग इंटरफेस VLAN 10 पे आ रहा है, डेस्टिनेशन मैक एड्रेस मुझे पता है कौन से इंटरफेस से भेजना है, 0/1 से भेजना है, पर इनकमिंग इंटरफेस और एग्जिट इंटरफेस दोनों VLAN 10 से हैं। हाँ, मतलब मैं भेज सकता हूँ, पर भेजने के पहले ये जो इंटरफेस है 0/1 वो ट्रंक इंटरफेस है, इस वजह से मुझे इस डेटा में एक VLAN ID ऐड करना पड़ेगा, that is 10, and it forwards the data. Switch 1 receives it. Switch 1 makes an entry for the source MAC address. Show MAC address table 8553. It was received on 0/1 and it is part of VLAN number 10. How does it know? Through the VLAN tagging. In the inbound side, we can see VLAN 10. So it makes an entry for it. The destination MAC is A20D. It should be sent out of 0/3, and the receiving interface and the exit interface both are from the same VLAN, and hence I can send it to PC number 5. So it forwards the data. Clear? Any question with this flow? Any question with this flow? Abhishek, Rishikesh, Kapul. So this same kind of flow, the same flow you will see between PC6 and PC8. If I try to ping 10.0.0.8, I will see the same kind of flow between PC6 and PC8 as well. PC6 is connected to VLAN 20 interface. PC6 sends the data. Okay. PC6 sends the data. Okay. Whatever the MAC address is. Let me assume 6666 is the MAC address. This is 888. Okay. Switch 1 receives it. Switch will make an entry that 6666 was received on 0/2 with an interface VLAN on the interface VLAN of 20. Which are the other interfaces? Do I know the destination MAC address 8888? No. Which are the other interfaces that are part of VLAN number 20? On the trunk interface, it will see this interface. So it will forward the data. But when it forwards the data, it will also add a VLAN of 20. Okay, it will add a VLAN of 20. But does it add VLAN 20? Exactly. क्या वो VLAN 20 ही add करता है कि कुछ और number add करता है? Let's say. As I said, it will add VLANs are in the form of hexadecimal format. So switch number 1, when it forwards the data, it will add a VLAN tag of 14. It adds a VLAN tag of 14. Now you may ask, it is 14? How? So as I said, it's in hexadecimal format. Hexadecimal format. So 14, number is 14. 1, 4. 1 in the form of binary is written as 0001. 4 in the binary format is written as 0, 1, 0, 0. And if you convert this into their respective decimal format, this is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 2 power 5, 2 power 6, and 2 power 7. So here only 2 power 4 plus 2 power 2. 2 power 4 plus 2 power 2 gives you 20. Okay, 16 plus 4 gives you 20. Okay, so that is why it was written as 14 in the hexadecimal form. In the hexadecimal form. All right, that's why it was mentioned as 14. It was mentioned as 14. Okay, so this is how the flow would be. So not, oh, sorry, the flow is going to be, I did not complete the flow. So it adds a VLAN tag of 20. Switch 2 makes an entry for it that it has received a source data of 6666 on the interface 0/1 with a VLAN tag of 20. It makes a note of it. Okay, the destination MAC 8888 is not present. So it checks which are the other interfaces that are part of VLAN 20. It finds only this interface, so it forwards the data to PC number 8. Clear? The return traffic is also the same. All right. Now, an interview question. I'm not sure if you guys have been following me on LinkedIn or if you guys follow me on Insta or if you guys follow me on YouTube. Pretty sure you would have heard this question from me. Or if you have seen my earlier videos, you would have seen me asking this question. But this is one of the most commonly asked VLAN based question. Okay. So question is, there are two switches. Switch number 1, switch number 2. All right. Two PCs are connected to it. PC1, PC2. IP address is 10.0.0.1/24, 10.0.0.2/20. This interface is access VLAN 10. This interface is access VLAN 10. Listen to me carefully. Access VLAN 10, access VLAN 20, access VLAN 20. Okay. Two PCs connected to two switches. PC IPs are 10.0.0.1 and 10.0.0.2. The two switches VLAN configuration are like this: access VLAN 10, access VLAN 10, access VLAN 20, access VLAN 20. The question is ping 10.0.0.2 from PC number 1. Question is, can PC number 1 and 2 ping each other? This is the question. Can you guys answer? Anyone? You can unmute yourself and answer also. There's no need to just type in the chat. Question is, can PC1 and PC2 ping each other? Can PC1 and PC2 ping each other? This is the question. Can anyone answer? Yes. सही गलत बाद में देखना. आपकी अंडरस्टैंडिंग क्या है ये मुझे जानना.
Like in between switch 1 and 2, you said it's access VLAN or trunk VLAN? 1020.
Access.
Okay.
Yeah. So if they can ping, why? If they cannot ping, why? I need both answers. अगर पिंग कर सकते हैं तो क्यों, नहीं कर सकते तो क्यों?
नहीं कर सकते लगभग, क्योंकि वो दोनों अलग अलग VLAN.
ठीक है. कोई और?
इसमें पिंग हो सकता है लक्ष्य, क्योंकि जैसे मैंने पूछा था कि ये बहुत ट्रंक पोर्ट नहीं, तो अगर एक्सेस सोर्स जब पिंग करेगा डेस्टिनेशन को, even if they are in different VLAN. But due to is access VLAN 10 on switch 1 facing to switch 2, it simply pass that traffic. They are not look for the tagging or something.
Okay, fine. Okay. Anyone else would like to say anything? Yes, no. Abhishek said no. Praful said yes. Rishikesh, Adnan, what are your opinion? Will they ping or no? Rishikesh says no. Adnan, your opinion?
Hello.
Hello.
Yes, sir.
Will they ping or not?
No, I think so.
No. Okay. Any reason? Rishikesh, what's your reason of no? See, this is an interview question. If you just simply say no, that does not stop your question there. The interviewer will ask you why. मैंने यही बोला था. No तो क्यों? हाँ तो क्यों? Explain yourself. This is how interviewer tries to understand your thinking. So agar, if any interviewer has asked you this question, he draws this particular diagram and he says, can PC1 and PC2 ping? You cannot just simply say yes, and you cannot just simply say no. You need to explain yourself. So start explaining, like what Praful did. He said yes, they will ping, and he gave an explanation. So if you're saying no, explain why. All right, no, okay. So if anyone asks you in the interview question this particular topology, and if you answer it correctly, okay, the interviewer gets an impression that your basic about switch and your basic about VLAN is extremely clear. अगर आपने इसका आंसर सही दिया तो इंटरव्यूअर को ये यकीन हो जाता है कि भाई आपका VLAN का कंसेप्ट बहुत क्लियर. That is why you have to listen to the question also very clearly. I said there are two PCs connected to switches: access VLAN 10, access VLAN 10, access VLAN 20, access VLAN 20. Will they ping or not? The answer is yes, they will ping. Yes, they will ping. Okay. Why they will ping? That's the explanation. Now, let's assume the MAC address of PC1 is 1111, PC2 is MAC address 222. All right. So PC1 sends the data. The switch receives it on interface VLAN 10. Okay. Switch receives it on interface VLAN 10. Let us also assume, okay, switch receives it on interface VLAN 10. Now, MAC address table, here then interface and VLAN. The source MAC address is 1111. Okay. The interface that it received on, let's say it is interface number 1, this is interface number 2, this is interface number 2, interface number 1. So it received on interface number 1, which was a part of VLAN number 10. Okay. Then, second thing, it checks for the destination MAC address of 2222, which is not present in the MAC address table. So what it does, it will broadcast it. When it does not know the destination MAC address, it will broadcast it. But before broadcasting, it will check which are the other interfaces that are part of VLAN number 10. It finds this is the only interface which is part of VLAN number 10, and it will broadcast it out of this interface. Switch 2 will accept it. Why? Why will it accept? As I said, this two interfaces are access VLAN 10. I just showed you when I was explaining this particular diagram, I said for an access interface. Here also on an access interface, when the switch accepted the data from an access interface, see, the switch accepted the data 0/1/0/2. Is there a VLAN tag? Is there a VLAN tag? Though we have configured it for VLAN 20, is there a VLAN tag? No, there is no VLAN tag. And when it is sending the data out of 0/3 to PC number 8, is there a VLAN tag? When it is sending the data outbound side, is there a VLAN tag? No, there is not a VLAN tag. So on an access interface, the VLAN tags are not present. So the data that is sent by switch number 1 to switch number 2 does not have any VLAN tags. When there is no VLAN tag involved, switch number 2 thinks that this particular data belongs to VLAN number 20. जब कोई VLAN tag उस डेटा में है ही नहीं, तो switch 2 को ये लगता है कि भाई ये डेटा जो आया है वो VLAN 20 के लिए आया है. ठीक है? For that reason, switch 2 will accept VLAN 20. And when it accepts this particular data, in its MAC address table, it will make an entry like this. Interface and VLAN. MAC of 1111, it was received on interface number 2, and it was received on an interface with a VLAN 20, because there is no VLAN tag. So, क्योंकि VLAN tag नहीं है, so this interface where it belonged, where it hit, that is the interface VLAN, so 20. So it checks which is the other interface. It checks for 2222. It does not find it. So it will broadcast. When it broadcasts it out of those interfaces which are part of VLAN 20, and hence PC number 2 will also receive this data. The return traffic. The return traffic. Okay, PC 2222, return traffic. So this particular data hits switch number 2. It makes a note of it on interface number 1, which is a part of VLAN 20. So it made a note, VLAN 20. Then it checks the destination MAC address. Is the destination MAC address known? Yes. Out of which interface should it send? VLAN 2. And is the incoming interface and the exit interface same? Yes, they are same. So it sends the data, but no tag. No tag, because it is access interface. So there is no tag. And when there is no tag, switch 1, when it receives the data, it does not see any tag. And when it does not see any tag, it assumes this to be a part of VLAN number 10. So it makes an entry 2222. Which interface was it received? Interface number 2. Which VLAN does this interface belong to? VLAN number 10. Good. Destination MAC address. Is it known? Yes. Out of which interface? VLAN number 1. Is the receiving interface and exit interface on the same VLAN? Yes. So it forwards. If you don't believe, let me show you this on a practical scenario. Ten dot 0.0.1. Okay, on the switches, let me configure Switch 1, enable configuration terminal, interface fast Ethernet 0/interface range, fast Ethernet 0/1-2, switch port, access VLAN 10. Okay. Then on switch 2 as well, enable configuration terminal, interface range, fast Ethernet 0/1-2, switch port, access VLAN 20. Okay. Now let these interfaces come up. I will show you the ping. So from PC number 1, I will ping PC number 2. Ping 10.0.0.2. See the reply. I'm receiving the reply. Why? Because let me show you that in the simulation mode, PC1, and PC1 pings. Obviously, PCs do not understand VLANs. So there is no VLAN ID over here. Anyway, it forwards to switch, which will make an entry, and it was received on access VLAN 10. Correct? It was received on access VLAN 10. And the outgoing interface is also access VLAN 10. So you see here, there is no mention. The inbound packet has no VLAN tag mentioned. Outbound packet also has no VLAN mentioned. So when the data is sent to switch number 2, switch number 2 gladly accepts it because there is no VLAN tag. There is no VLAN tag. And because there is no VLAN tag, it assumes it to be a part of VLAN 20. So in the outbound packet, there is no VLAN tag. There is in the inbound also there is no VLAN tag. Outbound also there is no VLAN tag. Okay. So if you still have doubt, let me explain you this from a real scenario. Imagine that there is a house and you are the only person living in the house. You are the only person living in the house. You. But you have a security guard over here. You have a security guard. Okay. And the security guard knows you are the only person who will enter the house and who will exit the house. Okay. So whenever you exit the house and whenever you enter the house, he has no problem. He is not going to check your ID. Who are you? Because he knows you are the only person who is living in the house. There is no point for him to check the ID. And there is no point for you to also carry the ID. Because you are the only person in the house. So there is no need for you to carry an ID card. Okay, but when you have a lot of people, you have you have you have your mother, have your father, you have your friends, brother, sister, all of you guys are living in the house. So that's when the security would start to check your ID because you are not the only person living in the house. There are a lot of other people living in the house, or instead of family, let's say there are other people also started to live in the house. You, okay, person number 1, person number 2, person number 3. There are 4 people living in the house. So these 4 people will exit the house, will enter the house. So whenever they exit or enter, they need to carry an ID card, which this security guard needs to check. Then only he will allow you. Then only he will allow you. Okay. Now, earlier, there was only one guy. There was only one guy. That is you. So there was no need for this security guard to check your ID. There was no need for you to carry an ID. That is the situation of access VLAN. That is the situation of access VLAN. Got it? Now, when there are multiple people living in the house, person 1, 2, 3, 4 living in the house, you, person number 1, person number 2, person number 3, there are 4 people living in the house. So now all of you guys need to carry an ID card so that this security guy can identify you. That is what trunk does. Trunk will give you an ID that you need to carry so that whenever you are going to someone else's house, it will check you with an ID card. It will check you with an ID card. All right, that is the work of a trunk. That is why over here in this particular scenario, in the access VLAN side, there was no VLAN ID involved. That is why the switches were able to allow these traffic to each other. Clear? This is the interview question. So if you have to answer, if someone asks you this question, you need to say, yes, they will ping. Because on an access interface, no VLAN IDs are tagged. That is why the switches will not understand the VLAN ID and they will accept. हाँ, दोनों डिवाइसेस पिंग करेंगे एक दूसरे को क्योंकि एक्सेस इंटरफेस पे VLAN टैग्स नहीं होते, जिसकी वजह से दोनों स्विचेस को VLAN टैगिंग के बारे में पता नहीं पड़ेगा और वो ट्रैफिक को एक्सेप्ट करेंगे. क्लियर? एनी डाउट? एनीवन? नो. अभिषेक, अदनान, ऋषिकेश, एनी क्वेश्चन? No question? Okay. Now the question is, what if the owner of this house comes? What if the owner of this house, the security guard knows the person is the owner of the house. He is not someone who is living as a tenant in the house. That guy is the owner of the house. Now the owner comes and the security guard knows he's the owner. And we all know that when the owner comes, the security guard simply says salam bhai and he just lets him. He does not check any ID because he knows he's an owner of the house. Right? That kind of work is what you call it as native VLAN. Native VLAN. Native VLAN are those VLAN which do not carry a tag on a trunk interface. Same way, here the owner is a native. Native मतलब उसका खुद का घर. He is the native of this particular house. The security guard is not going to check his ID. And the owner also, there is no need for him to carry an ID. That is the work of native. Okay, so let me add instead of, let me quickly change this particular diagram. enable. What I'm going to do is I'm again going to create VLAN 10, VLAN 20, and trunk interfaces between the switches. Right. So configuration terminal interface fast Ethernet 0/2 switch port access VLAN 10, then interface fast Ethernet 0/1 switch port access VLAN 20, then interface fast Ethernet 0/3 switch port mode trunk switch port trunk allowed VLAN 1 comma 20 comma 10. Okay. And then let's go to switch number 2. Enable configuration terminal interface fast Ethernet 0/2 switch port access VLAN 10, then interface fast Ethernet 0/3 switch port access VLAN 20, then interface fast Ethernet 0/1 switch port mode trunk switch port trunk allowed VLAN 1 comma 10 comma show interfaces trunk. Okay. Then here as well show interfaces trunk. Okay. Now, if you check over here, when I do a show interfaces trunk, you can clearly see native VLAN 1. So that means on this interface, if a data from an interface that is connected to VLAN 1, listen to me very carefully. If the receiving interface VLAN is 1, then on this trunk interface, that particular data, when it is being sent out, will not be tagged. Okay, let me explain you this. So when I'm sending a data from PC1 to PC2, ping 10.0.0.3, what's the problem? When 10 is there, then 20 is there. Ah, okay. Sorry, my bad. My bad. Obviously, it will not come. I configured yeah, these two PCs to be on the same link. So I'm trying to ping PC number 3, which is part of VLAN number 20. Obviously, it will not. So PC1 and PC4 should ping. Okay. PC, the two are pinging. So when they are pinging, okay, we would see a VLAN tag when the switch is forwarding the data out of the trunk interface, because the inbound or the incoming interface VLAN was VLAN 10, access VLAN 10. That is why on the trunk interface, the VLAN has been tagged with VLAN number 10. All right. Similarly, for VLAN 20 as well, we will see a VLAN tag of 20. But what if I add two PCs, PC number 5 and PC number 6, and I just simply add them. I will give them an IP address 10.0.0.5 and here 10.0.0.6. Okay, I'm just going to connect these two PCs on the switch. I'm not adding VLANs, and we all know that by default, every interface of a Cisco switch is part of VLAN number 1. So PC5 and PC6 are connected to the switch interface, which are part of VLAN number 1. Okay, whichever the interface that is fast in the 0/4 over. 0/4 is part of VLAN number 1. And obviously, this is an access interface VLAN, right? Now, let me ping PC5 and PC6. Okay. When I ping PC5, sorry, PC6, the data is sent to switch number 1. Please note this, that the incoming interface VLAN is an access VLAN 1. Access VLAN 1. VLAN 1. And as per the show trunk interfaces, on this particular interface, the native VLAN is 1. Thus, when the switch is forwarding this particular data, VLAN 1 data, there will be no VLAN tag on the outgoing trunk interface. Outgoing trunk interface. All right. Thus, switch 2 receives it. Switch 2 will not see a VLAN tag. And it also knows that on its trunk interface as well. Show interfaces trunk. On its trunk interface as well, the native VLAN is 1. That is why the other switch is sending a data without the VLAN tag of 1. Sorry, without a VLAN tag. That is why it also belongs to VLAN 1. So there is only other interface which belongs to VLAN number 1, that is PC6 interface. So it forwards the data to PC6. Okay, so on a trunk interface, native VLAN will not be tagged. And please bear in mind that this native VLAN of 1 is default. You can change this. This is the default VLAN. I can change the native VLAN, meaning that, okay, before I move to this particular part, any question about native VLAN? Anyone has any question regarding native VLAN? Abhishek, Adnan, Rishikesh, you guys have any question? No? Okay. So I can change, as I said, I can change the native VLAN. So let me make the native VLAN as 10 on both the switches. Configuration terminal. Okay. switch port. I have to go to the interface fast Ethernet 0/ what was it? 0/3. Okay. Switch port trunk native. Okay. Native VLAN. Native VLAN is 10. Okay. I will have to configure the same on switch number 2 as well. Configuration terminal. Interface fast Ethernet 0/1. Fast Ethernet 0/1. Switch port trunk native VLAN 10. All right. Now let's do a show interfaces trunk. Show interfaces trunk. So you can see here on this trunk interface, now the native VLAN is 10. Now the owner is changed. पहले owner 1 था, अब owner 10 हो गया. तो अब 10 जब ट्रंक VLAN से जाएगा, ट्रंक पोर्ट से जाएगा, 10 वाला VLAN में कोई टैगिंग नहीं होगा. All right. So let me ping from PC1 to PC4. So PC1 sent a data, switch 1 received it. Now check. When PC1 received the data, there is no VLAN. No, sorry, when switch 1 received the data, there is no VLAN. When switch is sending the data, there is no VLAN, because now the interface, incoming interface VLAN is 10, and that interface on the trunk port is a native VLAN. It will not be tagged. So there is no tagging over here. You can see there is no tag. Okay, it will forward to switch 2. Switch 2 will accept it. It will not see any tag. When it does not see any tag, it will say that it belongs to VLAN 10. The interface which belongs to VLAN 10 is fast Ethernet 0/2, and it will forward the data to PC number 4. Okay. Now, what will happen if I ping from VLAN 1 devices, PC5? Let me ping PC5 and PC6 again. What is going to happen? Switch 1, when it receives the data, there is no VLAN. When it receives the data, there is no VLAN. But now the VLAN, native VLAN has changed. That is why on the trunk interface, you will see a VLAN 1 being added. On the trunk interface, VLAN 1 is added. VLAN tag of 1 is added. All right. Clear? Any question regarding VLANs? What is an access port? What is a trunk port? How native VLAN works, etc. Any question? Because that's all you have to understand about VLAN. And in the interviews also, they will ask you question only from this, just to make sure, just to check your understanding of VLAN. Abhishek, Adnan, any question regarding any problem understanding what VLANs are? So that's it for today's class. I explained everything that I know of VLAN. Okay, we studied what VLAN is, how on a single switch, how VLAN works, on a double switch, how VLAN works, and on a double switch, what is an access port? Not double switch, multiple switches. On a multiple switches, what is an access port? What is a trunk port? And how VLAN tags are done on access and trunk. And I've also discussed one of the most famous question asked in the interview. Okay. So in the next class, that is tomorrow, I will start our discussion on spanning tree protocol, STP, spanning tree protocol. Okay. Anyone has any question or anything that you would like to ask, or you would like to discuss, or you would like to discuss about the course, etc. Any question, please feel free to ask.